Okay, welcome back. Michael Wickerson at Wickerson Studios. Um, Basically, I was just doing a very simple procedural model and putting it to an oriented grid that I could see how the model kind of breaks apart. And I'm doing this for uh, pretty much day one in my digital elective class, trying to get people to think procedurally, parametrically, computationally, and getting them into scripting and coding right away. And so you'll notice this little script parasite I've been using lately just so I can script in Visual Studio Code, because that paired with GitHub Copilot ends up doing an awful lot of looking at the documentation needed instead of going to something like which I do fall back on almost every time, falling back on the Rhino Common API. So you can get close with GitHub Copilot and things like that, which are pretty nice, and Chat GPT, but you'll probably have to go back to that documentation. But what this allows is that I've got a really nice script editor over here in Visual Studio Code. It's not really needed, but if you did want to check your scripts, you basically shift select both and group, and then just take that to a box or a blob, and then these two scripts will directly link in Visual Studio Code for the editing required. All I did here was create a pretty interesting little grid that no matter how many stages I go through, which is kind of interesting to think about what this means on a param viewer for those interested. If you're looking at a param viewer and you're taking a look at how many the paths, and actually I guess you can see it better in the panel tool. You'll see that you have your paths numbered. You have your whether it's a tree or a list or a single item. It's all kind of recorded there for you, but what I like to do is kind of visualize it over here. So I'm thinking about these points. If I had 6 steps to do, I could do that and add another one and have another iteration that would emerge over here. And all I've done is just added list items for these orient tools to take. The first tool we're doing is creating points and orienting them there. Then I'm creating curves and orienting them here. Everything's being generated pretty much around center. But then I can take it to the curves, just the perimeter curves, and I can take it to the breps, surface breps here, and then I can take it to the extrusions. And this is not a very complex model. Normally I would loft the curves through a range and they would kind of become bulbous and undulate out. But this is nice because you could really build your kind of this generative model as many stages as you want, and then you could be using Galapagos to optimize volumes and areas, which could be really interesting if you think about that. So keeping it simple, really just the 5 stages and just the one linear approach of transitions to what's happening. Basically, I'm trying to tuck a lot of stuff into a node, and then when the node gets a little too many outputs, I find it's a little overdone. But it's nice because you can see that if I changed anything here down from 4, it's going to influence everything as it goes along. And I've just kind of sized my grid accordingly to how big I might want to go for this Acropolis. If I went really big and beyond it, well, then I would have to set my numbers and change it up here parametrically. And I've also got my radius in here that I can produce. Um, oh, I can produce my radius that of each column as it goes up, and I thought that was enough. In fact, when I got to taking out the breps and taking out the brep extrude, I didn't find it was necessary. So the script was basically creating a point of line grids. A grid of points. Then it was creating circles with a radius of r, so that's parametric as an input. Up here, double r. And the only thing you have to remember with your C# nodes is that you have to set your types, and you have to make sure that these are accurately brought in as the access and as the types. And that will get you in trouble as you get into trusting GitHub Copilot or trusting in Visual Studio Code or Chat GPT. It might make sense to just have the points outputted, the curves, and the outer curves, and then with that I'm just using an orientation, which is really unnecessary. I could bypass all of this stuff here from this point, and I could say, okay, we're always going to be just grabbing this and orienting all of these points. Just shift control here, and that's going to clean up my script and make it a little more simple for everybody. So basically I'm orienting everything wherever I want to put that. Let's just put it up here. Everything is still working to that center. So that's pretty interesting. And I haven't done any scaling, so it's not having any problems, but it's pretty cool. And let me just bring that back down to maybe 4 and 6. Actually, I'll bring it back down to 3 and 4. So that's just a nice little column. Actually, I think it looked better as 4 and 6. So that's what I'll do. And that diameter. So once I've done that, and then I'm extruding a list of circles. And I thought it would be best to just take this one and possibly ungroup, then grab this one as the next node up here to shift and group to a rectangle. And now I've got a script that'll go live in Visual Studio Code, and you can see that I'm using an input curve list E, which then creates C breps created from, because it's a static function. So whenever you're dealing with breps or surfaces or curves, you definitely have to think about using a static. Can't call it from that particular instance. You have to call it from the class itself. So we're calling from brep. And then over here, surface, I'm actually calling using those same curves as the input, and then the radius is Z. And even though I could have tucked the vector in here, I thought it was easier just to throw a vector on here and then slide through. So you're deciding how much is necessary as we update that to script within your node, because you want a node that's kind of functional. Now, most of these nodes are all very simple. This is just a union between this tool and the extrude tool, which really is probably not the way you'd come at it. You probably would do just an extrude on curve or a move on curve, which you could have done as well, and then make a surface from a loft. So you're just thinking kind of computationally how you would make something, and then I probably would just, actually I don't think it capped anything. I'd have to cap each one with cap holes. So whether you choose this path or this path, you can decide where's the way you want to script, what's the lightest. And what's nice is you'll end up getting in here and you'll see how long on the Markov profile things take. So that's it. Just points, curves, outer curves, in case I wanted to get back at the other data as well. And what's happening with this is as you tuck into the C# nodes, you're finding it's a little less necessary maybe to get in here and understand all of the wonderful things I spent way too much time on, relative items and shifting paths and all this, and learning how to script these offsets. It's best to like stick with the common language that makes sense to you. Stick to your for loops for lists. That's pretty simple. Ranges and series can be introduced. But I think it's a nice little model that really will demonstrate how to work statically, how to work procedurally, parametrically, computationally, and then actually tie into jumping into GitHub, using AI with GitHub Copilot if somebody wants to spend money on it. And if you want Copilot, you basically get that and pay that $10 a month, or you could go so far as to use ChatGPT to get close with Rhino Common API, and you're learning how to use that as a coexisting. But it's a pretty simple model. There's nothing fancy about it. People could manufacture it very fast, but you're breaking it down and thinking algorithmically to what you need to do. So stop streaming, stop recording.